19, remove ends node from end of list from LeetCode. Given the head of a linked list, remove the ends node from the end of the list and return its head. So as you see in this example, this is the linked list that is given to us. N is 2, which means we should remove the second node from the end of the list. This is the first node, this is the second node, we are going to remove that, and this is the new linked list that we are going to return the head of the linked list. In this example, we are going to remove the first node from the end of the linked list, and it's going to be an empty list. And n is 1, we are going to remove the first node from the end of the list, and this is the linked list after removing the first node. And the question has constraint, which is very important here to read these constraints or ask questions about the like any constraint for the question. It says the number of nodes is going to be shown with SZ, and it can be between 1 to 30 nodes. And what is very important here is it says the n that is given to us is going to be between 1 and the length of the linked list. So the number of n cannot be bigger than the length of the linked list. So if we have 5 nodes here, n cannot be 6. This is not possible. This is not going to happen. It's always like it's equal to 5 or smaller than, and it cannot be negative either. So this is a very important constraint that we should have in mind, and it's going to help us to solve this problem efficiently. For solving this problem, we are going to use 2 pointers, a fast pointer and a slow pointer. And then we are going, as you see, we can define them here. We are going to use a the green arrow for the slow pointer and a red arrow for the fast pointer. Then what we are going to do, we are going to move the fast forward pointer n steps forward. N is, for this example, 2, so we are going to move the fast pointer 2 steps forward. So this is going to be 1, this is going to be 2. So after doing that, and this is the while loop that we do that. After doing that, we check if the fast pointer is pointing to null. And if the fast pointer is pointing to null, it's a special case that we deal that. But the fast pointer for this example is not pointing to null. So what we are going to do, we are going to do a while loop, and we move the fast pointer and the slow pointer 1 step forward at a time until the fast.next is null. And if it is null, we are done with the while loop. So let's do that. Is the fast pointer dot next is null? No, it is not. So I'm moving on this one step forward and 1 step forward for this one. If 4 dot next is null, it is not. I'm going to move this 1 step forward and this 1 step forward. If is 5 dot next null? Yes, it is null. So we are done with the while loop. Now, as you see, we know that the slow pointer is pointing to the node that we needed to delete. So we are going to move the pointer from pointing to the node that needed to be deleted to the one after that, right? And this is how we do it. We are going to say a slow.next is equal to a slow.next.next. So let's go through this example. In this example, we need to remove the second node from the end, which is going to be 1. So this is the first node, this is the second node. This is what we need to remove. What we are going to do, we are going to have a slow pointer and fast pointer. A slow pointer is going to be green, and the fast pointer is going to be red. So we are going to move n steps forward for the fast pointer. So this is 1 step and this is 2 step. And we know that n cannot be bigger than the length of the number of nodes that we have. So after moving that n steps forward, what we see is like the fast pointer is pointing to null, and if not fast pointer, what we are going to do, we are going to remove the head, because we know that that the slow pointer is pointing to the node that needed to be deleted, and this is a special case that we deal with it here. So we are just going to return the head.next, which is going to be node 2. The same thing here. As you see, we have a slow pointer and we have a red fast pointer. We are going to move the fast pointer one step forward, and now you see the fast pointer is pointing to null. And if it is pointing to null, we are going to return head.next, which is going to be null, an empty list. And that's how we solve this problem. The time complexity is on linear because we iterate over the list and linked list, and the space complexity is constant. Thank you.